Hello and welcome to Rationals 3.4, Graphing from Factored Form. Alright, so today we're going to graph rational functions, and it's not going to be easy. It's going to hopefully be not as bad as it should be, because we kind of got you ready with 3.1, 3.2, and 3.3, where we taught you how to get the vertical asymptote, we taught you how to get the domain restriction, and we taught you guys how to get the horizontal asymptote. So coming into this lesson with that kind of preparation hopefully makes this lesson a little bit easier. Okay, it's not going to be easy, but hopefully it's going to be a little bit easier. Okay, and a big reason why this is one of the more confusing graphs is it doesn't just have one look to it. Okay, so this first slide is going to show you two different ways that it could appear. Yeah, if there's a single asymptote in the function. Yeah, so some functions are going to have one asymptote, some are going to have two. So that's why it gets kind of confusing, because you never know what you're going to get until you actually just start prepping the graph and figuring out the pieces to it. So next slide, you're going to see what a two vertical asymptote graph could look like, and you can see that they have, I guess, some similarities, but not really. Yeah, so they all look very different, and that's part of the big reason why this graph is sometimes very confusing. Okay, so these are your 5 steps. We already did steps 1 and 2 as part of Rationals 3.2 and 3.3. Steps 3 and 4, they're pretty standard and straightforward. Find the x-intercept and y-intercept. Step 5 is the one that's going to be really, really humbug, and you're going to probably hate it, but it's not like it's going to be super difficult to do. It's just a lot of computation. Yeah, so you just got to get through it and you'll be fine. Okay, so let's get to our first problem. All right, so number 1, I kind of color-coded things where the different colors will connect to the different pieces that we have to find within this list of things that we have to do down below. So we're just going to start with the ones that are familiar, and we're going to do VA. Okay, so VA is going to be the bottom of your fraction, and it's going to be the number that you're going to use to find 0, or to make 0 rather. So you're going to look at the x, it's going to be combined with -3, so you're going to say to yourself, okay, so what number can I plug in place of x so that when I combine it with -3, it cancels it out and makes 0. Okay, so hopefully the number you're thinking about is a, and let me kind of match the color with the piece of the puzzle that we're trying to figure out. So hopefully the number you're trying to figure out is a 3, and if you did think of 3, very good. Okay, but just be careful, right? 3 is the number that's going to cancel out -3, but you got to write this as a vertical line equation, which means it has to start with x equals. So please make sure you put the x equals. Okay? All right, so since we've already done the VA, x equals 3, domain is pretty much going to look exactly like that, except we're going to go x colon x, not equal to 3. Okay? All right, so those are your first two pieces. That's what we learned in Rationals 3.2. Okay, rather than go straight to 3.3 right now, which is the horizontal asymptote, we're going to actually do the x-intercept, which is, I believe, step 3. Okay, and the reason why I'm going to do the x-intercept is because the way that we got the VA, where I looked at the contents of the pink box, is the exact same kind of train of thought that we're going to use to find the x-intercept. So we're going to look at that blue box right up top of that exact same fraction, and we're going to cancel out, we're going to figure out what number cancels out +1. Okay, and that number is going to be a -1. All right, so here's how you're going to do this. All right, so you're going to put -1 as part of your answer, but then you got to remember your experience from graphing other graphs, where if it's an x-intercept, it's supposed to appear as an ordered pair. So if you just write -1 in this line, you're not going to get full credit because it needs to be a coordinate. Yeah, and all coordinates of x-intercepts, hopefully you remember, have a 0 for the y value. And if you can remember that, then you'll be in good shape. Okay? Alright, so that's the x-intercept. Alright, and oh, just out of curiosity, if you guys were wondering, these two fractions, the left side fraction versus the right side fraction, the right side fraction is known as what is called factored form version of the rational function. The left side, the 3x plus 3 divided by 2x minus 6, that's the regular version of a rational function. Okay, so in this class, Algebra 2, we're going to be kind of nice to you. We're gonna factor the rational function for you so that you can grab the pieces you need, right? So on the right side fraction, the factored form fraction, you can grab the parentheses that's going to tell you the VA, you can grab the parentheses that's going to tell you the x-intercept, and it's going to be a little bit easier. Okay, but just a quick warning, when you guys get to your high-level math class, like trig pre-calc, they're not going to do that for you. Okay, they're not going to baby you. So enjoy it now. Appreciate what we're doing for you right now because we're making life a little bit easier for you on a problem that's already kind of difficult. So yeah, understand that when this problem gets given to you normally in non-algebra 2 type classes, yeah, your teachers are probably not going to be as nice. Okay? All right, so let's go to the HA, and this should also be very familiar. So you're going to look at the purple box this time, and in the purple box, you're going to compare the powers, the biggest power on the top, compared to the biggest power on the bottom. So let's see, what is my biggest power on the top? And in the box, you see it says 3x, so therefore you can assume that the biggest power is a 1, so n is 1. Then you look at the bottom, in the purple box, it's 2x. That's going to be containing your biggest power, so that's also going to be a 1. So n is 1 and d is 1. So this is going to be put in the category called same power. And hopefully you guys remember from that lesson 3.3 that same power means you grab your coefficients or the numbers in front of the x, so that would be 3 and 2, and you divide them. And when you divide it, that's going to be your horizontal asymptote. So we're not going to leave it as 3 over 2 like we kind of did in lesson 3.3 for some of the problems. We left it as an improper fraction. Yeah, but we're going to try to convert it into either a mixed number or a decimal. So you probably rather write this as 1 and 1/2 or 1.5. So 1 and 1/2, 1.5, either way is fine with me. Okay, make sure you do this though. Don't just write 1 and 1/2 or 1.5 on this line. You got to remember this is a horizontal line. So just like the vertical line, we had x equals 3. For horizontal asymptotes, we got to write y equals whatever that number is. So in this case, 1 and 1/2. Okay, so don't forget to put the y equals. Okay, so next up is the y-intercept. So hopefully from your experience with the y-intercept, you remember that every single y-intercept in the entire world has a 0 for the x value. And just knowing that fact is going to hopefully make finding the y-intercept a lot easier because it's basically going to tell you in one of your two fractions, you're going to plug in 0. And when you plug in 0, whatever is left after everything is computed, then that's going to be your y-intercept. Okay, so let's use you can use either equation, either fraction rather, but the one on the left seems to be a little bit easier because when I plug in 0, watch what happens. So I'm going to have 3 times x, which is going to be otherwise known as 3 times 0, then plus 3. Then on the bottom I have 2 times x, which is going to be known as 2 times 0, minus 6. Okay, and what happens from there is the 0 and the 3, the 0 and the 2, they're going to cancel it out. That's what multiplying by 0 does. It cancels things out. Yeah, so all you have left is positive 3 on the top, negative 6 on the bottom. So overall, your answer is going to be negative. Simplify your two numbers, and you get 1/2. So your y-intercept ordered pair is 0, negative 1/2. Okay, so I realize these are nice numbers to graph. Okay, but just try your best trying to draw the lines and try to draw the dots. I mean, I'm not expecting it to be perfectly exactly where it's supposed to be, but just get it kind of close. That's the main thing. Okay. All right, so let's start graphing these pieces. And as of right now in this problem, we're now done with the first 4 steps. Okay, we didn't get to step 5 yet. Yeah, step 5 is going to be a little bit more, I guess, intense in the sense that, well, okay, wait. I need to use the straight line tool of this software. So let's take advantage of the software and let's use it to make a straight line. So, all right. So I got my line at x equals 3. And then when you draw your asymptotes, you kind of want to make dashed lines because then it's going to be a little bit more unique and you're going to understand that this is a asymptote because you're going to see the dashed line. Okay, so I'm going to dash it. just like that. Okay, and you also want to do this. You also want to label what this dashed line is. So this is a VA. Oops, okay, this is too thick. Let's make it back to the thinner pen size. Oops, one more. Okay, so this is my VA, and this is located at x equals 3. Okay, so now let's draw my HA. So that's going to be purple. Okay, so this is going to be at a height of 1 1/2. So, like I said, you don't got to be perfect, right? It's impossible to make this exactly at 1 1/2. You just get it close. I mean, if you're way off, then yeah, I might mark you wrong. But if you're kind of close to it, then oh, okay. I thought I changed the color to purple. Maybe not. Okay. All right. So 1 1/2. All right. So that looks kind of good. All right. So let me dash the line. And oh, gotta make it a little bit thicker. Okay. So much things to remember to put in place and take away. So yeah, hopefully I don't forget to put things back to where they are as I do the rest of the problems. But I know I'm going to forget. That's a guarantee. Okay. So let's label this purple dashed line as an HA. Oh yeah, there I go. I talked about not forgetting to do something, and I forget to change the thickness of the pen back to the skinny. Okay, so this is HA. And this is at a location y equals 1 1/2. Okay, so please sure to label your asymptotes just like I did. All right, so now let's plot my x-intercept, and that's going to be at -1, 0. So that's right about there. And you've got to label that. Okay, the reason why you don't have to label the x-intercept dot is because there's going to be so much other stuff that I'm going to draw within the contents of the x and y axis that if you start having to label x-intercept and y-intercept and all that kind of stuff, then it's going to get kind of crazy. There's going to be so much stuff going on in the graph that you're going to just like you're just going to get confused. So don't worry about labeling that this blue dot is the x-intercept and that this teal colored dot is the y-intercept. Don't worry about that kind of stuff, okay? If we're dealing with a graph paper, that's pretty much, we're graphing on a graph paper, we're going to put one graph per page, per side of the paper, then yeah, maybe you can label it. But yeah, we're not going to make it that big, okay? All right, so that's steps 1 through 4. And now we're going to do step 5, the one that I said is going to be, not difficult in the sense of complexity, it's just going to be humbug because there's going to be so much computation. And here's what step 5 is going to accomplish. It's going to put a lot more dots on this graph, and once I get a lot more dots plotted, then I can connect all the dots and I'll be done. Okay, so that's what the whole purpose of step 5 is. So let me go to the next slide because that's what I'm going to use to get the next couple of dots that I'm going to put on the graph. Okay, so as you can see what I have on the screen here, everything in red is going to be what is consistent with every single rational function graph you ever do today. Okay, so all your tables for step 5 are all going to have 10 and -10 as two values you're going to plug in. And it's going to have right in the middle the vertical asymptote that we found earlier in step 1. Okay, so what vertical asymptote value did we find earlier in step 1? So let's uncover this box. And we realize, or remember, that it's a 3. Okay, so that shouldn't come as a surprise because we actually figured that out in step 1 of this process. Okay, and if you're wondering why does it say undefined right next to the 3, the x column 3, and it's because remember now this is a VA, and this number is 3. So if I plug in a 3, it's going to make a 0 on the bottom of the fraction, and if I get a 0 on the bottom of the fraction, it cannot be divided. So therefore, your response is undefined. Okay. So this 3 comma number that we can't figure out is not going to actually be a dot that we're going to put on the graph. Yeah, it's actually already on the graph. It's the vertical asymptote. Yeah, so it's already actually on there. We just hopefully realized it, but maybe you didn't. So now you do. Okay. And to get the rest of the numbers, here's what we're going to do. We know that the VA is at 3, so we're going to use that as my center point, and we're going to go one value bigger than 3, which in that case is going to be a 4. We're also going to use one value smaller than 3, which is going to be a 2. Okay? And then to get the corresponding y values for all of these x values, we're just going to plug it into our equation. The one that we have, that we're given in the problem, 3x plus 3 divided by 2x minus 6. You could use the other equation if you wanted to. Yeah, the one that says 3 times the quantity x plus 1 divided by 2 times the quantity x minus 3. You could use that one, that's fine. I just prefer to use this equation because it's a little easier to do things in your head. Yeah, I'm not going to require you guys to do calculations in your head, but yeah, if you can, it's a little bit easier to manipulate the numbers if you have it written or using this equation instead. Okay, so let's uncover what it's going to become when I plug in 10. So I'm going to plug in 10 multiplied by 3 on the top, add 3. Plug in 10 on the bottom, multiplied by 2, subtract 6, and when everything settles, we get 33 over 14, which becomes 2 and 5/14. Okay, and you're probably wondering, how am I going to graph 10 comma 2 and 5/14? Well, I'll show you. Okay, I don't expect you guys to be exactly at 2 and 5/14. That's impossible. Just get pretty close to it if you can. Yeah, so let's graph 10 comma 2 and 5/14. 10 comma 2 and 5/14. What color am I in? Okay, so let's pick the pen and let's choose a color. So I don't know, should I use a color that I already have? I guess I can. It's not going to make that big of a deal if I use a color that I already use. So let's just choose blue. So 10 comma 2 and 5/14. So here's 10 for the x-axis, and we're going to go up 2 and 5/14. So that's going to be maybe right about there. Okay, that might not be exactly 2 and 5/14, but it's close. Yeah, just get it close for me. You don't have to get it exact. I'm not going to be that picky. Okay. All right, so let's unhide the next value. So we're going to plug in a 4. And when I plug in the 4, here's what it looks like. You're going to go 3 times 4 plus 3 on the top, 2 times 4 minus 6 on the bottom. And when you crunch all the numbers, it's going to become 15 over 2, or otherwise known as 7.5. Okay, so let's plot the point 4 comma 7.5. Okay, so 4 on the x-axis, and then 7.5. So here's 6, here's 7, and here's kind of sort of half right there. Oops, I didn't change it to pen mode. Okay, I told you guys I was going to forget to do stuff, yeah? Alright, so here's 7.5. Alright, so let's go back to the table, and let's plug in our next number, which is 2, and let's see what I get. Okay, so plug in a 2, so 3 times 2 plus 3, and 2 times 2 minus 6, which becomes 9 over negative 2, which becomes next negative 4.5. So 2 comma negative 4.5. Okay, so let's plot that. 2 comma negative 4.5. So that's right about there. Okay, and then the last number we're going to plug in 10, or I'm sorry, negative 10. So 3 times negative 10 plus 3, 2 times negative 10 minus 6. And when you crunch all the numbers, we get negative 27 over negative 26, which reduces to 1 and 1/26. So let's plot that value. So negative 10 comma 1 and 1/26. So negative 10 and 1 and 1/26. So this is going to be super close to that horizontal asymptote, so just don't touch it. You can get pretty close to it, but just don't touch it. Okay, so I guess that's kind of decent enough. Okay, so here comes the part that students always get confused on every year. Okay, how do you connect all these dots? Yeah, it doesn't seem like the dots can all connect together, and the dots aren't going to all connect together because if you notice, this is a single asymptote graph, so it's going to look like one of these two things that I showed you guys in the first line. So it's more likely going to look like the graph on the left because you got some dots on the upper right, you got some dots on the bottom left. So it's probably going to look like the picture you see on the left side of this slide. Okay, because I think if you kind of remember, we had a dot right here, yeah, or a dot way up here rather, and we had a dot like right about here. Yeah, if I were kind of to guess. Yeah, and then for this guy, we had like a dot, and then a dot here, and then a dot there, and a dot here. Yeah, so I mean, I know these dots are not really at the exact same spot that it was in the problem we're doing, but it's kind of like the placement of the dots that I kind of remember from problem number 1. Okay, so we're going to try to form this graph based on the dot placement that we see on problem number 1. Okay, so we're just going to connect it as best as we can. Don't expect it to be perfect, right? Because you're doing this by hand, right? If I expected you guys to do a perfect graph, I would give you guys technology. I would tell you guys to graph it on some kind of like desmos.com and then just take a screenshot if I expected it to be perfect. Okay, so I'm not expecting it to be perfect. So just try to make sure you don't touch the horizontal asymptotes. Okay, and don't do this either because I see kids doing this all the time. Yeah, this is actually not correct. They do this. They do that. Don't do that. Okay. All right, you got to remember that as the line gets drawn, it's going to gradually get closer and closer to the asymptotes. So don't make it curve after you hit dot. Yeah, try to make it slowly. Try to approach the horizontal and vertical asymptotes just like that. And if you can remember, put arrows signifying that they go on forever. Okay. All right. So that's your first problem. You survived. Okay. I'm going to probably speed it up as I go through 2, 3, and 4 because otherwise I'm going to have an hour 20-minute video, and I don't think you want to sit through that long of a video, so let's just move on. Okay, number 2. Okay, so I'm going to go a little faster. So VA, we're going to look at the x plus 4 parentheses. We're going to figure out what number cancels out positive 4, and you're going to say negative 4. So we're going to write this as x equals negative 4. Then we're going to put the domain, which is going to look just like our VA, except we're going to put not equal to, and then negative 4. And then the x-intercept, we're going to write none. And the reason why we're going to write none for the x-intercept is because there's no x on the top. And because there's no x on the top, we can't solve for x. Yeah, we can't figure out what number is going to make it become 0 because I cannot turn a single 5 into a 0 because there's no number I can plug in. So therefore, since I can't find a number that's going to cancel out the 5 that's on the top, yeah, because there's no x to plug it into, yeah, then there is no x-intercept. So the graph, when you finally draw it, you're going to realize, oh, it's not hitting the x-intercept. Yeah. Okay, and then we got a HA. So we're going to look at the biggest power on the top. And let's change it to purple. So the biggest power on the top, actually there's no x. So since there's no x, your power on the top is 0. Okay, because the x is gone. So therefore the only way the x can be gone is if his power was 0. And your biggest power on the bottom, look at the purple box, that's going to be a 2. So this is going to be called the category bottom power bigger. Okay, so since D is bigger, this is known as bottom power bigger. And hopefully you remember what your horizontal asymptote looks like when it has the category bottom power bigger. So hopefully you remember that the equation is horizontal asymptote y equals 0. Okay. All right. Then we're going to do the y-intercept, which hopefully you remember from the previous problem, is all about plugging in 0. Okay, so we've been doing y-intercept the entire year, so hopefully this is not something you guys already have forgotten. So we're going to plug in 0. Wherever I see an x, I don't have an x on the top of the fraction, so it's just going to stay 5. On the bottom, I'm going to get 0 squared, which is basically still 0. I'm going to get 8 times 0, which is going to be 0. That's the beauty of plugging in 0. It causes everything to cancel out. And then plus 16. Okay, so when all the dust settles, this cancels, that cancels, we basically have 5 over 16. So I know this y-intercept is kind of weird. You're not normally plotting 5/16ths, but like I said earlier, yeah, just because you have weird numbers, I don't expect it to be perfectly plotted. It's impossible to perfectly plot 5/16ths. If I demanded perfectly plotted values like 0, 5/16ths, like I said, I wouldn't make you guys do this by hand. Yeah, I would just make you guys use technology if I expected it to be perfect. Yeah. Okay, so let's plot the things that we do have. So let's make my vertical line. X equals negative 4. Okay, so let's see if I can put this at the right spot. Yeah, that's kind of close. That's actually pretty close. Okay, and then let's label this line. Ooh, actually, let's label it first. I'll dash it later. So VA, X equals negative 4. Okay, now let's dash it. So let's turn it into the white ink. Make the stylus a little bit bigger, and let's dash this line. Okay, alright, so we're going to dash it because that's how all asymptotes should appear, as a dashed line. Okay, so let's put the stylus back to skinny, and let's make my horizontal asymptote. And this is going to be purple. Okay, and this is going to be a little bit harder to see because it's actually going to be located at the same exact spot as the x-axis. Alright, so here's my horizontal asymptote, HA, is located at y equals 0. Let's dash this line, make the stylus a little bit bigger, and let's dash this line. Okay, all right, there we go. Okay, and I cannot plot the x-intercept because my horizontal asymptote is actually on the x-axis, so that's why I don't have an x-intercept. But I can plot the y-intercept, so let's do that. So that's at 0, 5/16. Okay, so wow, that's kind of pretty close to the y-axis. I'm sorry, the x-axis. Yeah. So just draw it as best you can. I know it's not going to be perfect. I'm not going to expect it to be perfect, but just get it as close as you can. Okay. But don't like go extreme and say, oh yeah, the dot that I'm about to draw is supposed to be 0, 5/16, and draw it purposely way off. Yeah, from there. Okay, I guess that pink dot is not going to erase. I tried to do it the past couple of seconds and it's not erasing. Okay, so let's plug into our formula. And this time I'm going to plug it into the factored form of the equation. Okay? Alright, so let's plug in our numbers. So let's plug in 10. And notice, right, like I said, everything that is in red, that's what's going to be common to pretty much all your tables for every function that you're going to graph today. Okay, so you're going to plug in 10, you're going to plug in -10, because those are your extreme numbers. They're going to tell you what is happening on your graph on the far right hand side with 10, and what is happening on your graph on the far left side with -10. So you want to have those extreme numbers that are going to tell you what's happening at the far left and right ends of your graph. And then the three middle points, the VA plus the ones that are surrounding it, they tell you what the inside of the graph looks like, yeah, as far as what kind of action is happening there. Okay, so let's figure out what the VA was. Let's uncover that box, and when I uncover it, the number we see should not come as a surprise, -4. Yeah, we kind of knew that already. And since it's the VA, you know it's going to be undefined for the Y value. And then we're going to choose one number bigger than -4, so that would be -3. We're going to pick one number smaller than -4, so that would be -5. Okay, then we're going to just plug in these numbers. So let's plug in 10. So we got 5 on the top and 10 plus 4 squared on the bottom, which makes 5 over 196. I know that's a big number. Yeah, I know that's a big number, don't worry. Right? I'm not going to demand that you're perfectly at that value, just get it close. So 10 comma 5 over 196. That's actually super close to the x-axis. I'll try to get as close as I can, but yeah, there's no way I can get it that accurate. That's impossible. So I'll just draw a dot that's pretty close to the x-axis. How come it's not drawing? Oh, because I'm not in pen mode. Good job. Okay, so put blue ink. Let's try this again. Put a dot right there. Okay. Oh yeah, I was thinking, why is the dot so big? I guess I forgot to change the stylus back to small dot. Well, that's why my y-intercept dot was so huge. Let's actually change that because that dot is way too big. When I try to connect the dots, it's gonna seem kind of funny. So let's redraw it. Let's see if I can erase that pretty nicely. Okay. All right. And let's redraw that y-intercept dot. Okay. All right. That's a little bit better. Okay, so let's go back to the table. Let's plug in our next number, which is -3. So plug in -3, and oh wow, this came out as a nice number. Yeah, -3 plus 4 on the bottom becomes 1 squared, and that eventually becomes 5. So that's actually a nice number. Okay, so let's plot this value, -3 comma 5. Okay, so -3 is right here, and then 5 is up there. Okay, all right, that was easy to plot. Yeah, for once we got a nice coordinate to plot. That's kind of rare. Okay, so next number we're gonna plug in -5. So plug in -5. Oh wow, we have a nice number again. We have 5 again. So -5 comma 5. Wow, nice to work out that way 2 times in a row. If it happens to work out for you nicely like that in the future, don't always expect that. That's not how it's always going to be. Okay, so -5 comma 5 is right there. Okay, I wish all the values would be nice numbers like this, but it's not going to happen like that. That's not going to happen by far. Okay, all right, so let's plug in -10. And yep, once I say that, it turns back ugly again. So you get 5 over 36. Yeah, So let's plot this next dot. And I know I'm going through these table values pretty quick, but I know this is a video, so if you need to see how this 5 over 36 was calculated, yeah, just push pause and just look at the calculations that I do, right? Negative 10 plus 4 equals negative 6. Negative 6 squared is 36, right? So just push pause and just take a look at the numbers, yeah? I want to try to keep this shorter, so I don't want to have to explain all the numbers as they compute down the line. So yeah, I'm going to just kind of like bypass that kind of stuff. So just bear with me, okay? So negative 10 comma, and I forgot the number. 5 over 36, so pretty close to the x-axis, yeah? So right there. Alrighty, so let's connect the dots, and ooh, this dot placement looks kind of weird. Yeah, so let's go back to that very first slide to see what it kind of looks like. I think it's going to look like this graph on the right hand side, right? Because it looks like my graph, all the dots are on the top, and some dots are on the left, some dots are on the right. So I think it's going to be this right side graph right here. So let's connect the dots, and let's see what we get. And like I said, just remember when you connect the dots, try to connect it as nicely as you can. I mean, you can't be perfect, yeah, but just don't make it touch the asymptotes, and try not to make it do that curly thing when it hits the dots, yeah. Try to make sure it has the characteristic of slowly getting closer to the intercepts, okay, but don't touch it, yeah. So I suggest you probably do this in pencil, because if you make a mistake, then at least you can just erase it and just do it again. Yeah, because I got a lot of kids that their hand slips and the graph that they draw goes below the asymptote, and they're like, oh my goodness, yeah, it looks definitely wrong. So try to draw the lines as accurately as you can. Okay, and if you happen to make your hand slip and you're doing it in pen, just write me a little note on the side saying how it should look. Yeah. Okay, so number 3. All right, so let's do this, and this one is this is going to have 2 vertical asymptotes, because we have 2 x values that we have to solve in the bottom. So one guy is going to be negative 5. That's going to be used to cancel out the positive 5. So we're going to write x equals negative 5. And the x value that cancels out negative 2 is positive 2. So there's my 2x, my 2 VAs. My domain is going to be x colon x, not equal to negative 5 comma 2. Okay? Alright, and then, we have a x-intercept this time. Last time we didn't have one because there was no x in the top. Now we have one back again. So we know that all x-intercepts have number comma 0. That's a characteristic that we know for a fact. Okay, and I've been telling you that ever since the first quarter of this this course. So what number cancels out positive 1? And hopefully you say negative 1 does that. And if you do, good job. Okay. Alright, so HA, you're going to look at the biggest power on the top, and that's going to be a 1. You're going to look at the biggest power on the bottom, and that's going to be a 2. So we're in the situation of bottom power bigger. And if we're in the situation bottom power bigger, do you know what the HA is going to be? Do you guys remember? And if you do, good job. And if you say y equals 0, awesome, excellent job. Okay? Because bottom power is bigger, and whenever bottom power is bigger, your HA is always y equals 0. Okay? Alright, so let's do the y-intercept, and hopefully you guys remember, like I've been saying the past couple of times, every single y-intercept in the entire world has a 0 for the x value. So we're going to plug in 0. Okay, so let's do this. So we're going to plug in 0 wherever I see an x, so 0 plus 1. And on the bottom, we got 0 squared plus 3 times 0 minus 10. And the beauty about 0 is that it makes things disappear. So that's gone, that's gone, that's gone, and all we have left is positive 1 over negative 10. So that's negative 1 over 10. Okay, so let's put that as the other half of the y-intercept formula. Okay, alright, so let's start plotting this out. So this is going to be a 2 vertical asymptote problem. So it's going to be a little bit more complex. And yeah, just bear with me. Oops. I gotta use my vertical straight line tool. Okay, so what is that? Negative 5. So let's draw. Oh my goodness, didn't change the color, or I thought I did, but maybe I didn't. Okay, so take 2. Okay, there we go, finally got it right. So we got the VA at -5. We have another one at 2. Is that accurate? No, that's way off. Oh my goodness. Why did my eyes think that that was accurate? Maybe because it's getting late and my eyes are getting tired. Okay. Alright. So let's label these things. Both of these guys are VAs. The left side VA is at -5. The right side VA is at 2. Okay. Okay. And then let's graph the HA. Oh, what am I doing? I guess I'm not using the straight line tool. Oh man. Yep, it must be getting late. Yep, wrong color. Oh my goodness. Get it together. You're making a video. It's embarrassing. Okay, there you go. Alright, and then let's label this thing. Okay, don't forget purple ink, purple ink. Okay, so HA, Y equals 0. Alright, and then let me dash these lines. That's why I'm kind of like saving it so that I can just do all the dashes at once. So let's dash the line. And oh my goodness, I'm dashing line, but I forgot to change the thickness of the pen. So okay, alright, let's just get this going, because we're already at the 36-minute mark. So I'm so sorry that this video is on the longer side, but I think you guys know why, right? This is not a section that can easily be explained very quickly. Yeah, it's kind of intense, and if I go way too quick, you guys are going to be like lost, and at that point you're going to say like, why should I watch the video? It doesn't make any sense. It goes too fast. Yeah, so yeah, sorry if it's on the longer side, but I don't want to just rush through it. Okay. Okay, and then let's plot the x-intercept, so that's -1, 0. Let's plot the y-intercept, that's 0, -1/10, so that's like super close to the x-axis. Yeah, and I think that's everything that I can plot so far. So let's go to our table, and here's where you're going to be like, oh my goodness, what is going on here? Why is a table like supersized? Okay, because you got to remember, yeah, the standard things you need to do are you got to plug in 10 and -10. Those are your extreme values, the far left and the far right. Yeah, +10 is your far right dot, -10 is your far left dot. And then you got 2 VAs, so therefore you're going to have 2 middle points that you have to surround. So yeah, this table, because of the second VA, it causes a lot more issues. So here's my 2 VAs. 2 and -5. My numbers that surround 2 and -5 are 3 and 1. My numbers that surround the -5 are -4 and -6. Okay, so let's plug in the numbers. Let's plug in 10. Okay, and when you plug in 10, you get 11/20. Yeah, and let's plot this 10, 11/20. 10, 11/20. So that's like probably halfway. Ooh, why is the dot so big? Oh yeah, because I made the dashes and I used a thicker pen. Okay, there we go. All right, so now let's plug in 3. So plug in 3, we get half. Yeah. So let's plot the dots. 3, half. 3, half. Okay, right there. All right. Ooh, I think when I plotted 10, I said 11/20. It's 11/120. Sorry about that. Okay, and then we're going to plug in 1. So crunch all the numbers, you get -1/3. Finally, like a normal looking kind of number. Yeah, when you see -1/3, you can be like, yeah, that's like normal compared to the other fractions that we've been getting in the other problems. Yeah. So -1/3. So 1, -1/3. So 1, -1/3. Right about there. Okay. Just try to plot everything as best as you can. Like I said, it's not going to be perfect. It's impossible. Yeah. Okay, then we're going to plug in 1, or negative 4 rather, and we get 1/2. So negative 4 comma 1/2. Okay, so negative 4 and half. And then you're thinking, wow, those dots in the middle, they're kind of funky. Yeah, what's going on with them? They look kind of weird. Yeah, so don't worry, I'll compare it to one of the graphs that we have on that second slide of this slideshow, and you can see which one it kind of best looks like. Yeah. Okay, then we're going to plug in negative 6, and when I plug in negative 6, we get negative 5/8. So negative 6 comma negative 5/8. So negative 5, negative 6 comma 5/8. So that's right about there. Okay, and then let's plug in negative 10. Wait. Oh, I thought I put it to pointer. Okay, so I can drag this box. Okay, so negative 10 comma negative 3/20. Okay, negative 10 comma negative 3/20. Ooh, negative, wait. Okay, yeah, that's at the right spot. Yeah, I kind of second guessed myself. I said it in my head, but I thought I put it on the wrong spot. Okay, all right, there you go. So you got some dots on the top for the extreme right side. You got dots that are on top and bottom in the middle, and you got dots on just the top on the far left. So let's see what kind of graph exhibits this kind of characteristics on that second slide that I showed you. So dots on the top on the far right, dots on the top and the bottom in the middle, and dots on the top on the far left. So it doesn't necessarily look like any of these graphs, but I think it looks more like this I guess maybe this middle guy. Yeah, I'm sorry, this one on the right. Except this L that's on the left hand side, we're going to put that L on the top. Yeah. So it's going to kind of look like this graph on the right. I mean, I guess it could look like the graph on the left too, but since that middle portion is kind of funky, I'd rather compare it to this graph on the right hand side. So let's plot the dots. And I'll say this again, I said this many times already. Yeah, when you plot the dots, you're not going to be perfect. That's impossible. Yeah, so just draw it as best as you can. Yeah. And try to make sure that this is a curve. I mean, I know when I drew it just now, it looked like it was kind of like a right angle, but just try draw it as best as you can. It's not going to be perfect, right? And then you're going to have it curve down. Oops, yeah, it really hit that dot. So let's try this again. Okay, then just remember not to touch that asymptote, but just get as close as you can. Okay, and then we're going to draw it going up. All right, and on the left side, same thing. So okay, whoa, that's like super ugly, sorry. Yeah, so as you can see, my graphs are super ugly. Yeah, so don't worry if your graphs are equally as ugly, right? I'm not expecting Picasso or Monet as far as the artwork of these graphs, but just try to do your best. Yeah, that's all I can ask. All right, okay, last problem. We're in the home stretch. Okay, so let's get this done. All right, so our VAs, we got a VA at -3, so x equals -3. We got a VA at 5, so x equals 5. That's going to create restrictions at two numbers, -3 and 5. Okay. Then, oh wow, we got 2 x-intercepts. I don't think we had that before. So we got 2 x-intercepts. So I'm going to write 2 separate coordinates with comma 0 for each. And then the x plus 1, -1 cancels him out. The x minus 2, +2 cancels him out. So yeah, gonna get tricky. We got 2 x-intercepts. We never had that before, but there's no rule that says we can't have 2 x-intercepts. Okay. And in the HA, let's see, what are my powers? Okay, biggest power on the top is 2. Biggest power on the bottom is also 2. So you're going to grab your coefficients and you're going to divide them. Yeah, because this is same power category. So we're going to grab the number on the top, -3, grab the number on the bottom, which you don't see, so we know it's a 1. And when this gets simplified, you get -3. So there's your equation for the HA, y equals -3. Okay. And in the last piece of this list, you're going to get your y-intercept, and it's going to be 0, comma number. So you're going to plug in 0, the easiest number to plug in the world, because it cancels things out. So negative 3 times 0 squared plus 3 times 0 plus 6. And like I said, you like to plug in 0 because it's just going to make things cancel out. Okay, all right, that purple line is very distracting because it's going to make you guys think it's a minus sign, which is not. Okay, so you got 0 squared minus 2 times 0 minus 15. So a whole bunch of stuff cancels out, right? All the things that multiply by 0 just pretty much cancel out. So all that's gone. So we get equals, negative answer. We're going to simplify 6 and 15 by 3, and we get 2/5. So 0, comma negative 2/5. I know that's not a nice value to plot, but hey, you just got to get it close. I've got to get it perfect. Okay. So, okay, I know I'm going to mess this up again because I'm going to forget to do something like change the color or change the thickness of the stylus. So, yeah, just bear with me. Okay. So, negative 3. There's my VA. VA at 5. Okay, so far so good. Let's write what these guys are. This guy is a VA at x equals negative 3. This is a VA at x equals 5. And then, okay, let's draw my horizontal asymptote. And that's at negative 3. So negative 3 is right there, I believe. Did I get it kind of good? Like I said, my eyes are getting tired, so I'm hoping that's actually pretty decent. I think it is. Okay, so this is a HA, and that's at y equals negative 3. Okay, so label these lines now. Don't forget to do that. Okay, so now I can dash them, make the pen size bigger. Oh wow, so far so good. I'm going to knock on wood. Yeah, I haven't forgotten anything yet. And watch, I just bring that up, and I'm going to forget something on the very next thing. Okay, let's hope I don't, but it's probably going to happen. I just jinxed myself. So make my dashes, indicating that these are asymptotes. Okay, I wish this software came with an option that said draw the line as a dashed line. If it could do that, that would be so awesome. Maybe it can today. I just haven't figured it out by pushing the right button. But yeah, I guess I could do a little more exploring on the software, but I'm just too lazy. That's not good. Okay, so change the stylus back to skinny. And let's put blue ink because I'm gonna plot the x-intercepts. So I got an x-intercept at negative 1, comma 0. Got an x-intercept at 2, comma 0. And then a y-intercept at 0, comma negative 2/5. So I think that's right about here. Okay, wow. So far so good. Yeah, I don't think I made any mistakes as far as forgetting to do something. Wow, that's kind of awesome. Alright, so let's get to our table, step 5. And oh my goodness, the ugly table again. Yeah, but it's like I said, it's standardized, right? You got your standard numbers, extreme number on the right, positive 10, extreme number on the left, negative 10. You got your 2 VAs that we already know what they are, right, from the previous step 1 from the previous slide. And that's going to be 5 and negative 3. And we're going to use the numbers that surround 5, 1 up and 1 down. So what number is 1 bigger than 5? A 6. What's 1 smaller than 5? That is a 4. What number is 1 bigger than negative 3? So that's negative 2. And what's 1 number smaller than negative 3? That's negative 4. Okay, so let's plot our first number, 10. Okay, so we're going to plot 10. We're going to crunch all the numbers. We get negative 4 and 4/65. Okay. So let's get this ready. I want blue ink, I think. So let's plot this dot. So 10 comma negative 4 over 4/65. And negative 1, 2, 3, 4, and then a little bit lower than that. Oh, so what am I doing? That's not negative 10. That's negative 6. Okay, right here. Sorry about that. And let's get rid of that dot that I drew in the wrong spot. Okay. See, I talked about doing it nicely on the like 30 seconds ago, and I made a mistake. Good job. Okay, so I think that's good. Yeah, that looks good. Okay. All right, let's uncover the next box. So plug in 6, you get negative 9 and 1/3. So 6 and negative 9 and 1/3. 1, 2, 3, 4, 5, 6. And what was the number again? Oh my goodness, I totally forgot. Negative 9 and 1/3. Negative 9 and 1/3. So that's right about there. Okay, alrighty. Next number we're going to plug in is 4. So plug in 4, we get 4 and 2/7. 4, comma, 4 and 2/7. So 1, 2, 3, 4, and 4 and 2/7. So that's right about here. Okay. Alright. I don't know why that random box keeps on jumping on. I guess maybe I don't know how to push the screen with my stylus too well, so that box always seems to appear every single time I put a dot. Okay. Alright, let's plot our next dot by plugging in negative 2. And when I plug in negative 2, I get 1 and 5/7. So negative 2, 1 and 5/7. Negative 2, 1 and 5/7. So I hope that's right about there. Yep, see, it's doing it again. I put the dot and that strange box appeared right away after that. It's just probably me. I just probably don't know how to push the screen with the stylus. Okay, and then let's plot the next dot by getting the value, the coordinates for negative 4. Wow, that's a nice number. First time. So negative 4, negative 6. I wish all the dots could be like this. That'd be so nice. Negative 4 and... oh, I got so happy about the nice value that I totally forgot what it was. So negative 4, negative 6. Okay. Negative 4, negative 6. Right there. Wow, that feels strange to put it right on that crosshairs. Okay, last one. Negative 10. And then negative 3 and 3/5. Negative 10. Wait, what am I doing? I went the wrong way. Negative 10, negative 3 and 3/5. So right about there. What's going on? Oh, I didn't change the pen. Okay, sorry about that. Okay, there we go. Alright, so let's connect the dots, and I think it's going to be curves, like L-shaped curves on the far left, and an L-shaped curve on the far right. Okay, make sure you try to draw curves, yeah? Don't connect these dots with straight lines. Draw them kind of curvy. And in the middle, it's not going to look like problem 3's middle. It's going to look more like a parabola. Yeah? So it's going to look like this. Alright, so this is going to kind of bring back memories from like the first quarter, where you have to draw quadratic function graphs. Alright, and I think we're done. Yeah? And yeah, we're finished. 53-minute video. Sorry about that. Had a lot to get done, but yeah. If you survived all 53 minutes, good job. I salute you. Okay? So I will see you in class. I'm assuming you're going to have a ton of questions. Don't worry, I'll have a ton of answers to come with all your questions that you have. Okay? Alright, so good luck on this assignment, and I'll see you in class. Bye-bye.